These are notes 10C, solving exponential equations. You will be taking these notes on your own paper. All right, take a moment and write down the following steps for solving exponential equations. So step number 1, isolate the exponential term. Step number 2, rewrite in like basis, if possible, and set exponents equal. Step number 3, use definition to rewrite in log form. And step number 4, you possibly may need to use your calculator to solve these equations. All right, if you need some more time to write down the steps, please pause the video. All right, example number 1. We're going to solve the equation 9 to the 2x is equal to 27 to the x plus 1. All right, we notice that 9 and 27, we can rewrite these both with a base of 3. So that's what I mean by same basis. So we're going to rewrite our equation. So we're going to rewrite 9 as 3 squared to the 2x. And we're going to rewrite 27 as 3 to the third to the x plus 1. So if the bases are equal, then the exponents must be equal. So we can set, now 2 times 2x is 4x equal to 3x plus 1. And we're just going to solve that equation for x. So let's distribute that 3 and get 3x plus 3. Combine like terms, so I'm going to subtract 3x. So we're going to get x is equal to 3. And so that's our solution, 3. Now in class, I'll show you how to check these on the calculator. So if possible, look to see if you can rewrite with the same basis. Unfortunately, all problems can't be rewritten with the same base. So look at the following example. We're going to solve the equation 5 to the 2x minus 1 minus 8 equals 2. This is an example where we want to isolate and change the form. So what you're going to have to be able to learn with these is, like I said, looking at the different equation, which method are we going to go about solving them, because it's not always the same method each time. All right, so we want to isolate the exponential part of the equation. So we're going to isolate the 5 to the 2x minus 1. So I'm going to add 8 and get 10. All right, I still can't rewrite 5 and 10 to the same base. All right, so since I can't rewrite them with the same base, what I want to do is I want to change the form. When in doubt, change the form. So this is exponential, so I want to change this to logarithmic. So it's going to be log base 5 of 10 is equal to the exponent 2x minus 1. So now once it's in this form, I can solve the equation. Now this is going to be a decimal, all right? But don't change it to a decimal yet. We'll do that at the end, okay? So let's solve for x. That means I'm going to add 1. So I'm going to have log base 5 of 10 plus 1 is equal to 2x. And now I'm just going to divide by 2. So log base 5 of 10 plus 1 divided by 2 is equal to x. Now this is an exact answer. All right, so depending on how the problem tells you to leave it, that's a great answer. That's an exact answer. It's not rounded. However, you may need to get a decimal approximation, and that's when, if we're going to check it on the calculator, that's what we're going to get. So we need to be able to change this to a decimal. All right, so all I'm going to do is put this in the calculator just like it looks. All right, so let's pull our calculator up here for a moment. So I'm going to type this in, that expression that I got, into my fraction template. So log base 5 of 10 plus 1 over 2. So that means I'm going to get the decimal approximation of 1.215. Now, like I said, depending on how the problem asks you to leave it, it's approximately 1.215. And in class, I'll show you how to check this on your calculator. So exact answer, and then we have the approximation. All right, let's try some more. All right, write down this problem. 3 to the 2x minus 1 plus 2 equals 0. All right, so the first thing you want to do is isolate that exponential part of your equation. So we're going to subtract 2. So I've got 3 to the 2x minus 1 is equal to negative 2. All right, same base, 3 and negative 2. I can't rewrite those with the same base. So that means I'm going to change the form. So when you can't rewrite the same bases, your next step is see if you or change the form. So we're going to rewrite this in the logarithmic form. So log base 3 of negative 2 is equal to 2x minus 1. All right, hopefully at this point you're going to say, I got a negative in that log. And you're going to recall back from our previous unit is that a log, base b of y, the base has to be greater than 0, and that y has to be greater than 0. Well, negative 2 is not greater than 0. So that means this is not possible. So therefore, what does that mean? All right, we can't solve for x. So that means this equation has no solution. So you're going to have to watch out for things that don't work because of, like I said, the definition of logs. So this equation would have no solution. So watch out for those negatives because our bases have to be greater than 0, and our term in the log has to be greater than 0. So we can get things that don't work. It's not a really extraneous solution because this doesn't have a solution. So that's something that's different. Okay, let's try another one. All right, write down this equation. So 7 to the 2x plus 3 is equal to 12 to the 4x minus 1. All right, so I look at this 7 and 12. Well, I can't rewrite the bases. This is going to be the most algebra-intensive question that you're going to have. All right, so here's how we're going to go about solving this. I've got to get those exponents, those variables out of the exponents. And the way that I'm going to do that is I'm going to take the natural log of both sides. You could also take the log of both sides, but natural log is a little bit easier to do just because the fact natural log always has the base of e. So that's one less thing I have to worry about. Like I said, get ready for your algebra because this has a lot of algebra in it. All right, so step number 1. So if I can't rewrite them with the same basis, I can't isolate and change the forms because I have got 2 exponents here. This is your third option for solving. So I'm going to take the natural log of both sides. Because as long as I'm an equation, if I do the same thing to both sides, I'm keeping that equation balanced. All right, natural log of both sides. All right, now I'm going to use those properties that you learned back in 10b to start rewriting this. I'm trying to get that variable out of the exponent. So I'm going to use the quotient property. So I'm going to rewrite this as 2x plus 3 times the natural log of 7 equals 4x minus 1 times the natural log of 12. All right, so I use that power property. I think I called it quotient property before, but it's power property. All right, now it just turns into algebra. I've got a natural log in there, so I'm going to distribute my natural log of 7. So I've got 2x natural log of 7 plus 3 natural log of 7. Distribute my natural log of 12, so I got 4x natural log of 12 minus natural log of 12. All right, my goal is still here the same. I'm trying to get my x's together, my variables together, and my non-variables together. So combining like terms. So I'm going to rearrange this equation a bit. So I'm going to subtract this term, okay? And I'm going to subtract that term. All right, so I'm going to rewrite this as 2x natural log of 7 minus 4x natural log of 12 equals negative natural log 12 minus 3 natural log 7. All right, remember the whole goal is to get x by itself. So hopefully at this point you see that both of these terms have this x. So I'm going to factor that out. I'm going to factor out my x. So that makes, and I know I can factor out a 2x. Remember, I want to get x by itself. So I just want to factor out the x. I'm saving myself a little bit of work here. All right, so x, that leaves me with 2 natural log 7 minus 4 natural log 12. is equal to natural log 12 minus 3 natural log 7. Alright, now here again, remember my goal, get the x by itself. So that means I'm just going to divide by this entire term. And I've accomplished my goal. Alright, so we're going to have x is equal to negative natural log 12 minus 3 natural log 7 all over that entire expression, 2 natural log 7 minus 4 natural log 12. And this is an expression. I can't cross out any of my natural log 12s or my natural log 7s. Alright, so still all the properties of rational expressions that we learned back in Unit 8 still apply here. Now you can put this in the calculator and get an approximation. So the approximation here, this is approximately equal to, when you put this in the calculator, 1.376. And here again, I'll show you in class, or remind you in class how to check these answers. Okay, so that, like I said, if you can handle that one has the most algebra in it. Alright, so like I said, we've solved exponential equations. Let's go solve some logarithmic equations. Alright, so take a moment when we're solving log equations, you got to remember the following. Recall that the definition of log base b of y states that b and y are positive. Remember, they're both greater than 0. The base has to be greater than 0 and y has to be greater than 0. For equations, this means you may get extraneous solutions. So we're going to state the domains first for each log or natural log equation before solving it. So you got to watch out for extraneous solutions when you have logs and natural logs. So let's try a couple. Alright, write down the following equation. Log base 5 of 2x plus 3 equals 3. Alright, here again, I want to isolate and then I'm going to change the form. It's all about recognizing how to go about this. And in any equation, we always want to isolate that variable term first. Alright, now let's stop in for a moment. Let's state the domain. Let's state the domain of this, our 2x here. So 2x has to be greater than 0. So that means our solution, x, has to be greater than 0. Alright, so we're going to check any solution against that domain. Okay, let's go back and let's isolate. So we're going to subtract 3. So we get log base 5 of 2x is equal to 0. Alright, I want to get that 2x out of that log. So in order to be able to do that, I'm going to change the form. So I'm going to rewrite this in exponential form. So 5 to the 0 power is equal to 2x. Well, anything raised to the 0 power is equal to 1 equals 2x. Solve for x, so we're going to divide by 2. So x is equal to 1/2. Alright, let's check to see if that's extraneous. Look back at our domain back up here. Alright, is 1/2 greater than 0? Well, yeah, it is. So that means that's okay. It's not extraneous, so that means it works. So our answer is 1/2. Alright, so like I said, don't forget when you have log and natural log equations, don't forget to check the domain for extraneous solutions. Alright, let's try another one. Alright, so solve log. Now, what's my base here? There's no base written. What's the implied base? Hopefully you said 10. Okay, common log base 10. Okay, so write down the following problem. So log 5x plus log x minus 1 equals 2. Alright, let's look at the domains. Notice I have two separate x's here. That means I'm going to look at the domain for both of these. So 5x has to be greater than 0. So that means x has to be greater than 0. And x minus 1 is greater than 0. So that means x has to be greater than 1. So it has to meet both of those conditions. So we're going to check when we get our final answer, make sure it meets both of those conditions. Okay, so let's solve this. So what are we going to do? We have those two logs. I don't want that. So this is why we learned those properties back in 10b. So we can use them to solve an equation. Alright, so remember what happens. If I've got logs that are adding, I'm going to use the multiplication property and I can turn them back into multiplication. So I'm going to make this log base 10 of 5x times x minus 1 is equal to 2. So I have to get, so in order to be able to solve these equations, I'm going to have to put my logs back together. I'm condensing them. Remember, we expanded and condensed in our last unit. Okay, now I'm going to change the form. So it's in logarithmic, so I'm going to rewrite it in exponential. So it's going to be 10 to the second power is equal to 5x times x minus 1. Now, as like I said, just back at a quadratic equation. We're going to solve for x here. Alright, so let's do this. So we're going to have 10 squared is 100 is equal to 5x squared minus 5x. So since it's a quadratic, I want everything to end up on one side. I'm going to rewrite this as 5x squared minus 5x minus 100 equals to 0. And I'm going to end up with two solutions. Alright, we have a common factor of 5, so I'm going to divide everything by 5 and get x squared minus x minus 20 equals to 0. Alright, let's factor what multiplies to give us negative 20 but has a difference of negative 1. So negative 5 and 4. Since I don't have a lead coefficient other than 1, I can just go straight to my factors. Alright, use the zero product property, so I can set x minus 5 equal to 0, x plus 4 equal to 0, so x is equal to 5, and x is equal to negative 4. Alright, remember we got to check for extraneous solutions, so let's go back up there and look at those domains. Alright, 5. Is 5 greater than 0? Yep. Is 5 greater than 1? Yep, so that one's good. Alright, how about negative 4? Is negative 4 greater than 0? Well, no. Well, of course, if it's not greater than 0, it's not going to be greater than 1, so that one's extraneous. So your only solution is 5. Alright, so please don't forget to check for extraneous solutions when you're looking at log and natural log equations. Alright, look at the following. So we did a natural log equation now. Alright, so write down the following equation. Okay, alright, let's look at our domains again. So 7x minus 4 has to be greater than 0. So that means 7x has to be greater than 4. X has to be greater than 4/7. Alright, also 2x plus 11 has to be greater than 0. So 2x has to be greater than negative 11. X has to be greater than negative 11/2. Has to meet both of those conditions. Alright, actually this one's really easy. Because if they both are natural log, that means so what's inside the parentheses must be equal to each other. So we simply have to set 7x minus 4 equal to 2x plus 11 and solve for x. So let's combine like terms. So subtract 2x, we get 5x minus 4 equals 11. We're going to add 4. 5x equals 15. Divide by 5, so x is equal to 3. Alright, let's check for extraneous. Does we meet both conditions? Is 3 greater than 4/7? Yes. So if it's greater than 4/7, we know it's greater than negative 11/2. So that means this is okay, it's not extraneous, so our solution is 3. Alright, so I kind of showed you one of each. We're going to practice in class. I will also have more practice questions in a separate video. So like I said, if you need to, good way to study, get ready to, like I said, something you want to see another example. Also, view the extra practice. Alright, if you have any questions, please make notes and we'll talk about them in class.